Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we look at properties of logarithmic functions, and we're going to look at those properties for different bases. So let's look at some of these properties. We're going to look at the properties for a general base B, base 10, and base E. So, the first property, log base B of 1 is 0. So log base B of 1 is 0. So that's for any base. So log base 10, or just log of 1, is 0. And natural log of 1 is 0. Okay, so log base 1 is 0. The second property, log base B of B is 1. For this property, we pretend this imaginary 1 is there. So the log base B of an exponent with the same base, all that cancels out and it leaves 1. So log of 10, which we know the base is understood to be 10 here, log of 10 is 1. And natural log and E, because they are inverse functions, they cancel out and leave this imaginary power of 1 as well. The next property is a generalization of the previous property. Log base B of B to the x is x. So there again, log of base B with an exponent with a base of B, all that cancels and it leaves x. Log of 10 to the x is x. And natural log of e to the x is x. For the same purpose, you have the same base on the log as you do on the actual exponent. The next property is b to the log base b of x equals x. Again, you have a base of b as that exponent, and then your log has base b. So when those bases are the same, everything cancels and it leaves that x. So 10 to the log of x is x, and e to the natural log x is x. So those are some properties that we're going to use to help us evaluate logarithms, and later on it's going to help us to actually solve some logarithmic equations. So let's look at some examples. The first one, we want to evaluate log base 8 of 1/8. Now, we had a property that said log base 8 or log base b of b to the x was x. So let's see if we can rewrite this 1/8 as 8 to some power. Well, yes, 1/8 is the same as 8 to the negative first power. So we can use our property of log base b of b to the x equals x. So everything cancels and it's going to leave that exponent of -1. Our next problem, log base 8 of 1, well, we had a property that said log base b of 1 was 0, no matter what b was. So that is just 0. The next problem, 5 to the log base 5 of log base 5 of 27. Well, here you have your base of the exponent is 5, the base of the log is 5, all that cancels, and it leaves the answer of 27. The next problem, we have log of 10 to the 6th power. Remember that when there is no base on the log, it's assumed to be 10. So if I write a little 10 there, I have log base 10 of 10 to the 6th. Then we can use our property where the bases are the same for the log and the exponent, and that cancels to leave 6. Next, we have natural log of e to the 8th. Well, I can write 1 over e to the 8th as e to the -8th. And then the natural log and e will cancel, and we're left with -8. This next problem, we have e to the natural log 9x squared. Well, that e and that natural log, again, will cancel, and we have 9x squared. So, remember that Dr. LB is always in. Please come back for more math help.